Hi, my name is Andrew Yule, and I work for Assured Flow Solutions. Today I'm going to be talking about effectively utilizing NETLink for application development with the Wolfram language. My name is Andrew Yule. Thanks you guys for coming to my talk. I'm going to talk a little bit today about application development with the Wolfram language, and specifically how to utilize NETLink and communicate with .NET. This is kind of a continuation presentation for me from last year. I kind of talked on a little bit more of a broad topic about how to develop applications with Wolfram language, specifically how to distribute them with enterprise CDF. So this is diving into a little bit more details on .NET side of things. So just a quick outline, we're going to talk about background, motivation, how I kind of came about looking into some of this stuff. We'll talk a little bit about .NET, and then kind of the meat of the presentation is going to be broken up into two parts. The first part is going to be really quick, though, basically calling Wolfram language from .NET. And then the second part, which I think is the real focal point, that's going to be calling .NET from the Wolfram language. So just a little bit about me. My background is in chemical engineering. I work in the oil and gas industry, and I've been using Mathematica and the Wolfram language for my entire career, so 6 years now. So I work for a company called Assured Flow Solutions, and we're a specialty engineering consulting company. And what we do is solve production-related issues in the oil and gas industry. We use kind of a combination of two things. One is simulation modeling to sort of simulate fields and flow of oil and gas and water through pipelines. And the other thing that we do is we have a production chemistry lab where we can actually take oil and gas samples, and run them through a variety of tests to sort of characterize the fluids and look at some types of issues that you can have with production. So within the oil and gas industry, what we do is known as flow assurance. It kind of sounds a little funny to the outside industry. But basically what we're doing is assuring that you've got flow of hydrocarbons, and that's actually a little bit more difficult than it sounds. Especially most of our work is offshore, so if you can imagine really harsh environments, you've got ultra deep water. You're producing from reservoirs that are sometimes 20,000 feet below the surface. So it gets pretty tricky. You've got a lot of really cold temperatures, high pressures, and that kind of creates an environment where you can have a lot of production-related issues. So here is an example of if you have an oil sample that's got a lot of asphaltenes in it, under the right conditions, those asphaltenes will precipitate out in your pipeline. If it gets bad enough, it'll completely block your pipeline. Similarly, here's paraffin content. This is long saturated hydrocarbon chains that'll precipitate out in your pipeline as well. This is actually an image from one of our lab equipment. It's called a rocking cell. And what it does is it rotates up and down, but you fill it with gas, with your actual hydrocarbon gas and water. And what you try to form are these things called hydrates, and that's that little white ice-like structures there. Basically, the interesting thing about them is that they're very similar to ice, but they actually form above the water's freezing temperature. So bottom of the ocean floor is a couple degrees above freezing. So it's the perfect environment for these with high pressures. And that ball in there, as it rotates up and down, it moves back and forth. And if it gets stopped, then you know, kind of qualitatively that you would have a blockage in your line. So background. So we as a company a couple years ago, we're kind of facing this challenge, and I think it's something that to some level a lot of companies probably face, specifically engineering companies. What we had was we do all this modeling, and we had a lot of data that we have to post-process, and for that we had a lot of Excel spreadsheets to handle that, a lot of VBA macros, and even one-off kind of executables. And so it was very poorly managed, and we ended up having a lot of different versions of different things, and it became really difficult to find the right thing for the job, and let alone which version to use. So what we tried to do was we created this thing which we called Alex, and it was named after the Library of Alexandria. And what it is it sort of attempts to kind of capture all of those utilities in a consistent and maintainable way. So I chose to do it in the Wolfram language because of Wolfram language flexibility and its math functionality. It makes it really easy to prototype things and develop them really quickly. So the calculations, the majority of it, there's about 41 of them in there, and the majority of them are calculations. There's also a lot of like workflow type things to help us kind of simplify data and things like that. Just to kind of give you guys a quick little preview. This is kind of what it looks like. And I'm just showing a few of them here. But some of them are really kind of simple calculations, and others of them are actually very detailed. So for example, this one right here is it actually lets you build in insulation on a pipeline and simulate a cool down time, which is if you were to shut in your pipeline at time 0, how long do you have until you reach some temperature that you're concerned about for hydrates or wax or any type of issues. So it's using ND-solve, and it's a pretty sophisticated calculation, actually. There's a lot of other things. On our lab side of things, we have a lot of equipment that we integrate with. They produce a lot of data, and trying to make sense of that data is something that we have utilities to do as well. Like in this one, for example, we actually take a sample, oil sample, run it through a differential scaling calorimeter, and we can take that raw data, and from that we can get a wax precipitation curve, which is sort of what this is. And as you drop temperature, how much wax do you precipitate out of your oil sample? So there's a lot of integration both on the engineering side and also on the lab side of things at our company. So as we were kind of going through this, we kind of came to a point where we realized that there was a few areas where we needed something more. We use a lot of simulation software, a lot of thermodynamic software, things like that, and all of those, a lot of them have the ability to interface with them through different APIs and things like that, and some of them are written in .NET. We also have plotting libraries that we use to actually generate reports for slides and things like that. And so we realized that there was a need for us to kind of look into some of this .NET interface, and specifically NETLink, because Alex was already written in the Wolfram language. We wanted something to keep it there as well. So that was kind of where all this came from, and I've started to spend some time with NETLink. And I just kind of want to share in this presentation some of the things I've learned. A lot of it is going to be in the documentation center if you kind of dig for it, but there's some really good stuff in there, and I think it's worth talking about and worth kind of showing examples of. So just real quick, I'm sure everyone here has heard of .NET before, and most of you probably know more about it than I do. But it's basically the foundation for most of Windows and the majority of the programs that Windows run on nowadays. Key feature is that the language can be compiled into .NET Common Language Runtime. So that's why you have things like C#.NET, VB.NET, C++.NET, all these different languages still running within the .NET framework. And then the other nice feature now is that they're quickly sort of starting to expand to other platforms. So now with things like Mono and Xamarin and things like that, you can run .NET on the Mac OS and other places. So it's starting to get a little bit of a broader reach to other platforms as well, which is kind of cool to see. So why do we need .NET? As I mentioned it in the last slide, access to things like forms and Windows controls and things like that you might want to have access to. Third-party DLLs, like sometimes you might have sophisticated solvers or math-related functions that have already been written in DLLs, and you don't necessarily know all the details of those to rewrite them in the Wolfram language, and so you just want to be able to access them. And then there's other things like interfacing with Excel and stuff like that. So I'll have to apologize for this. For the rest of this, I'm kind of going to go through it very quickly just because I want to kind of show you guys a lot of examples real quick. And so I might kind of braze over some of the finer details, but if you have any questions, feel free to grab me and we can talk more about it. Or if you have additional knowledge and things to share as well, I'm still learning some of this myself as well. So, yeah. So this first part, I'm just going to show kind of some quick examples of how you can call the Wolfram language from .NET. So if you've got some application that you're developing in .NET, the majority of what you're doing is on a UI side of things, and really you just want to call out to Wolfram language to perform some calculation that you really don't want to write yourself, right? So this would be an example where you would do that. You can create a link to the math kernel. So this is it's kind of a snippet of C# code. You can create a link to the math kernel, and then you can send your calculations through a number of different ways. Kind of one of the most common ones is this. So mathlink.evaluate to output form. And because Wolfram language has a full form functionality for everything, you can sort of do a full form on anything that you wanted to do and then put it into a string and then send that to the computation. Yeah.
Is there mathlink being deprecated by the
I don't know, actually. So, so if I run this, So you can see, it works. You'll see a little math kernel pop up. And the reason for that is because I close it here. So it starts up and it closes. If you wanted to keep it persistent throughout the application, you could do that as well. And it'd probably be a lot faster to do some of these. In this example, instead of evaluating to output form, I'm actually evaluating to an input or to an image form. And then so I can then directly load that image in right here. So. Just a few things to keep in mind on this. Like I said, this is really more for you're building something in .NET and you just want to call out to Wolfram for a few quick calculations. That's when you can use this. There's a couple DLLs that have to be present in your application directory. That's the Wolfram.NET link DLL, and then these ML32 or 64 I4 DLLs. Okay, so kind of moving to the rest of the presentation is going to talk about NETLink. So just to introduce it, it's a technology integrated into Mathematica, and it allows for direct communication with .NET. Obviously, you have to have the .NET framework or some equivalent installed on your computer. But really, the heart of it is, it gives the ability to work with .NET, kind of the Wolfram touch, as I like to say. So one of those benefits is that it lets you work in a truly interpreted environment. So some real brief syntax to get NETLink, you call needs NETLink. You install the NETLink. Now here I have an example of a class. So a class called person. I have two properties in here called first name, last name, and I initialize those properties through the constructor by passing in those arguments. So to create that object within the Wolfram language, you use the function called netNew, and I'm going to instantiate a new instance of the person class, calling it from this DLL where the code is actually contained, and then I'm going to pass in John Doe, and it returns back this net object. And so in order to get access to those properties within .NET, you can use either the @ sign or the functional sign exactly the same way you do any other function within Mathematica. So here's a kind of example to simulate one of those scenarios where you might have some function that's already been written in .NET DLL and you need to just call out to it. So in this case, I have a calculations class. It's got some really simple function in here to perform addition between A and B. So I instantiate a new instance of my calculations class, and then I can directly call that function now. Perform addition, pass in 2 + 2, and returns back 4. One little bit more interesting example is you can actually, using this variable in here called standard link, when the Wolfram language creates a link to .NET, if it's done via that path, the standard link actually gives you a link back to the Wolfram language. So in this case, I've got some function here. I'm going to say, what is the value of A? And this standard link is going to call back to my actual Wolfram language kernel. And when I evaluate A, it's actually going to tell me what it is. So if I say, OK, A is some text, create a new instance of my class, and then I ask, what is the value of A? It's going to return that. And then, of course, if I change the value of A, it's going to give me some new value. So kind of a way to get back and forth communications between Wolfram language and .NET. So to create, by default, when you create windows within .NET, in the Wolfram language, you can call system.windows.forms.form, I think it is. If you want to access WPF, which is the Windows Presentation Foundation, you just need to first load this net assembly, which is the presentation framework DLL. So once you've loaded that, I'm going to create a quick little function here that's going to create a new system.windows.window, and then just assign some height and width to it. So now when I show that, I can see, okay, I've got a live window, so that's working. Just a few kind of special assemblies. Lots of things can be loaded via the load net type. So in this case, I'm not going to run through this, but you can load this net type Windows startup location, and I think it's an enum. And if I create a new window, I can actually specify that I want that window to be in the center screen using the context syntax. Okay, so kind of got some of the kind of fundamentals out of the way. I wanted to talk about what it means to work in a truly interpreted environment, which is what NETLink gives you. So if I create I've got this new function here that's going to create some content that I'm going to put in my window. So I'm coming back here, I create a new WPF form, I'm creating new content for that form, and then I'm assigning the content to that new content that I create. So now when I show this, it's running. I'll kind of put it off on the side here. Now, as opposed to a compiled language where if I want to make changes, I need to stop the program, make a change, recompile, and then restart it. Here, if I load this net type for brushes, I can change the color of the application immediately. So now it becomes light gray. I can come down here, I can load a few other types so I can specify alignments correctly, create a function that's going to give me a button, so of a type of system.windows control button. And here I'll just set some of my alignments so that it shows up a little bit better in the window. So I create that button, and now I say, okay, my original window content had a dock panel, so you can access the children of that dock panel, and then you can go and add another control to it. So it's kind of the way Windows WPF works. So now if I come back here, I've got some button in there. So I didn't have to compile anything, I didn't have to stop anything, add it and recompile, which is kind of neat. Similarly, I can add a text box, kind of using the same idea. And then I've got some blank text box. So these are really kind of basic examples, but just show you kind of what's possible, which is pretty cool. There's even functionality within NETLink, to add event handlers. So if I create some function called WPF func, what that's going to do is it's going to set my text box that I added, the text property, to the date string. So if I create that function, and now I'm going to add an event handler to that WPF button, when the click event is triggered, it's going to call that WPF function. And so now I can go and see if all this works. So hopefully it does. It does. So something kind of cool just to show you what you can do in an interpreted environment. So, okay, so while all that stuff is really cool, and there's a lot that you can do with it, certainly you're probably not going to write an entire application in that path, right? So I think you kind of need some better way. And this is where I'm kind of at this point, and I'm kind of looking for that better path, better way to do this. If you're familiar with WPF and .NET, you've probably heard of MVVM, which stands for Model View View Model. It's basically a design architecture where you try to isolate your UI and your view from your model. And your model would be your business calculations, your data, your SQL queries, things like that. And then in between those, you have this view model that sort of acts as the interface between the model and as the view. And I'm definitely not an expert on this, but you can kind of get the gist of what it's trying to do and why it's trying to do it, right? You want to separate your UI as much as possible from the business logic calculations. So if we were to do something like that in the Wolfram language, what would it look like, right? And there's probably a number of different ways that we can do this. I'm still kind of trying to figure out the best way possible, but I'll present what I have right now. So this is just a screenshot from Visual Studio. So I'm designing some make-believe application here, and I'm really using Visual Studio for what it's best at, right? Which would be designing this user interface. The code behind this, I've got this button, and I'm going to create a new object called button1, and then in my constructor, I'm going to set that button1, which is this actual control, equal to this public property called button1, so that I have access to it. So now, if I come down here and I create a new WPF form, I create a new instance of this example window that I created, and it has a little bit more in it, you'll see, than the screenshot. This is an old screenshot. But I can create an instance of that. I can set the content, and now I can show it. So, okay, so I've got all that done. I've got the UI created on the .NET side of things, but Wolfram language is really what's controlling this. So now if I create some function here, button1 func, it's just going to print now. I can add an event handler to when that button gets clicked. It's going to call that function. So now if I come back here, you can see it's working, right? Everything's hooked up and it's working. So this is cool. So what else does this let us do, though? Well, it lets us do a couple things. So it lets Wolfram language do what it's best at, right? Which is computation, logic, things like that. And then it lets .NET show some of the UI side of things, which is probably what it's good at as well. If I close this example and do a couple other things. So I'm going to recreate all that. Now in my button one function, I have this status property within that UI as well. And so now I can actually set this status while the calculation is performing. I can simulate some long withstanding calculation, and then I can set the input, and then I can change the status of it back to ready. So just to show you what that would look like. So it's running now. Now I've changed some status. So this looks really basic, but if you tried to do something like this in .NET, it's a lot more than 5 lines of code, which is what you can do on the Wolfram language side. So it's pretty powerful stuff. Similarly, just one kind of final example. So it lets the Wolfram language do computations, which is great. It lets Wolfram language interface with the UI, which is great. What if we even let some of the UI logic be performed by Wolfram language as well? All right, so I'll run through all these again. Now I've got some function in here that's going to filter. I have a list of names that's going to show up in that last text box. And when you change the text on there, it's going to go through that property, access it, do a string, do a cases function on it, find any that are matching the string that I put in, and then filter the names on there. So, and then I add an event handler this time instead of clicked. I've got a text box in there, and the event that I'm linking this up to is the text changed event. So let me get some. So here's some of the names. So you can see, like, if I start searching for Adam or Nadine, things like that. Right. So this is just an example to show you kind of what you can do. You know, in this case, I'm even letting Wolfram language handle my UI logic. So it's pretty powerful stuff. So just a few extra items. I kind of brushed over it in those last examples, but there is a difference between show versus show dialog on a window. If you want the Wolfram kernel to be dedicated to what you're doing on the .NET side, make sure you're using show dialog. If you're on the Windows form instead of WPF, it's sort of similar. You can call do net modal as opposed to do net modalless. And all that's in the documentation too if you want to look it up. Lastly, you need some way to debug, and you can do that. So when you create a link to .NET, this program here called installable net gets created. And so in Visual Studio, you can actually go and attach to that process. And when you call something from the Wolfram language and you hit some breakpoint on your actual code, it'll work exactly like you would any other program. And you can debug it. So kind of conclusions. So like all of Wolfram's technology, NETLink is a really powerful tool. If you are looking for some application that just needs to call to the Wolfram language really quickly, you can do that. If you're trying to do something really advanced with .NET development, consider prototyping it in the Wolfram language, or at least helping you do some of the automation with the Wolfram language. And lastly, just experiment with NETLink. That's kind of how I've been learning some of this stuff, and I think you'll find that a lot more is possible than you might imagine. So. Any questions? Yeah.
Yeah, so you mentioned that one of your main reasons for doing this is that you can use other packages, kind of feed into the .NET, and then you can access that quicker than the Wolfram language. So have you made any progress with that?
Yeah, we have. We have some thermodynamic kind of simulators that we use. So we've automated some of the process of kind of generating fluid characterizations and things like that. Like a lot of what our workflow will be is you kind of input as much as you know about a particular oil sample, and then from that you have to generate these massive kind of PBT tables, which will give you all those characteristics at different temperatures and pressures, and then you feed that into the simulation. And so we've kind of automated some of that stuff with it. We have some plotting libraries that we use that I would do with the Wolfram language, but these plotting libraries let you do multiple, like a lot of different axes, so we can compare numerous different variables at the same time. So to generate some of those plots, we use the NETLink now, so we have functionality to do some of that with as well.
Did you do much error handling around what happens if .NET crashes, Mathematica crashes, the link crashes?
I haven't gotten into it a lot yet, but obviously definitely something that we have to be aware of and try and figure out the best way to handle it. Yeah.
We buy a lot of third-party components, like grids and charts and stuff.
Yeah.
.NET. So those components also are Spring.
Yeah, if those the people that produce those allow you to, if they have public APIs or anything that's available that you can interface with. If they're written in .NET or even some older components, some older legacy type things, you can interface with that through NETLink. Yeah. Yep.
Are there any features that you think are missing from .NET?
I've been really impressed with just some of the interpreted environment type of things. So I haven't really found anything that's missing yet. Probably maybe as I get into it a little bit more, I might have something else.
One thing I noticed is .NET was written before Windows Presentation Foundation existed.
Right. It was
So
written.
it seems to be like, since the UI stuff in .NET is really oriented towards the old Windows forms.
Yep.
Maybe are there some things that don't work quite as nicely with them?
I haven't seen anything actually, and the only catch that you had to have was loading that presentation framework DLL, right? Yeah, that's really it though. Yeah, I think WPF is a little cleaner looking and a little bit more modern, so that's why I chose to use it. But yeah, does it? Okay. Thank you.